Hello everyone. Today we'll be going through Cambridge International AS and A Level Mathematics Paper 4 Mechanics 970942 Feb March 2021. Let us move to question number 1. Question number 1 says two particles P and Q of masses 0.5 2 kg and 0.3 kg respectively are free to move in a horizontal straight line on a smooth horizontal plane. P is projected towards Q with speed 0.5 meter per second. At the same instant, Q is projected towards P with speed of 1 meter per second. Q comes to rest in the resulting collision. Find the speed of P after the collision. So this is 3-mark question. Basically, we will try to draw the diagram first to understand better. We can draw P and Q. Draw over here. This is like P and a smaller one. So P is this one, and also we can draw Q. So we can draw a Q which is a little bigger one. So we can draw Q like this. So this will be RQ, and we can move it a little over here, so like this one. And this is situation before the collision, and they are saying like over here, this is the situation before the collision, and after the situation after the collision, situation will be a little different, and that situation will be that we will move it closer to this one. So immediately after the collision, this will be the situation. So now we can understand this is before collision. We can write here before collision, and this one is after collision. These will be the situation. Now this is P and this one is Q. This is P and this is Q, and mass of P is 0.2 kg. So MP will be equal to 0.2 kg, and mass of Q is what? Mass of this is mass of P, mass of Q will be equal to 0.3 kg. This is mass, and velocity situation is that P is projected towards Q with a speed of 0.5. So UP is to this side with 0.5 meters per second, whereas UQ is, so direction of motion we can show like this one. This will be the direction of motion, and UQ will be equal to minus 1. Why minus 1? Because direction is the opposite. So minus 1 meter per second. So this is a situation before collision, and after collision they are saying that Q comes to rest. So VQ will be equal to 0. VQ will be equal to 0, and velocity of P will be opposite direction to this one. So this P we need to find. We need to find this velocity after the collision we need to find. So now we can write down the equation. Momentum before collision will be equal to momentum after collision, and momentum before collision will be what? Before collision will be UP MP. This will be momentum of P plus momentum of Q will be UQ MQ, and this one we can calculate. This will be 0.5 will be the velocity of P, so we can write 0.5 into mass of P will be 0.2, and plus UQ will be minus 1, and this will be multiplied by velocity which is 0.3, and further we can simplify UP MP plus UQ MQ will be equal to, we can simplify this by the help of calculator. So 0.5 multiplied by 0.2 and plus this will be minus 1 into 0.3, and this is equal to decimal value will be minus 0.2. So minus 0.2 will be this what do you call momentum before collision, will be the collective momentum of both objects P and Q basically. Now we can calculate momentum after collision. So after collision will be Vp into mass, which is 0.2, which will remain this one, and plus the other Q, mass of Q multiply by 0, mass of Q multiply by velocity is 0. So this will be equal to momentum before collision, and before collision momentum we have calculated, which is minus 0.2. We can write minus 0.2 like this. So we can move a little over here, and now we can simplify. Vp will be equal to Vp will be equal to minus 0.2 over 0.2, which is equal to minus 1 meter per second. So this will be velocity of P after the collision, and minus sign velocity of P after the collision will be minus 1, and direction will be to the left. So direction to the left. So this will be, this is 3 marks question which we are done. Now we can move to question number 2. Question number 2 says a car of mass 1400 kg is traveling at constant speed up a straight hill inclined at an angle of alpha to the horizontal, where sine alpha is equal to 0.1, and this is a constant resistance. There is a constant resistance force of magnitude 600 Newton. The power of the car's engine is provided 22,500 watt. A part show that the speed of the car is 11.25 meter per second. Now we can draw a simple diagram to understand this one. Like over here we can draw an inclined plane like this, and we can, so this is the inclined plane with alpha angle, and this is the car we can draw over here. So this is the car with mass, so mass is acting downward like this one, so W will be acting downward, and there is a engine force which is pushing it upward like this one, and this force is F is equal to, force is equal to what? Power over velocity, power over velocity. This is the relation which we will be using, and there is a resistive force that will be to this direction, which is 600 newtons is to this direction, and it is provided that sine of alpha is equal to 0.1, and alpha is equal to sine inverse of 0.1. We can check, and this will give us alpha, which is 5.739. We can check with the calculator. It's basically not required, but I have just written over here in case we require that. Then a acceleration is 0 y0 because constant speed, traveling at a constant speed up a straight hill. So we can write here a is equal to 0, in brackets we can write speed constant. So, and the relation we know, power is provided, which is this one. So power is equal to power is equal to force into velocity. So this means F will be equal to power over velocity. So this will be the relation. Now we can resolve this mass, basically weight, we can resolve this and we can understand the forces. We can resolve this force, and if I redraw properly, so we can draw solid line even, and this will be like this one will be this will be y component and this will be x component, and this one will be this one we can take as alpha. So this will be, this one we can take alpha, so this will be w sine of alpha and this will be w cos of alpha, and this is what we have resolved. Now we can balance the forces. The right hand side will be F will be to the right side, and we can write F is equal to what? F is equal to leftward force will be W sine alpha and 600 Newton. These two forces will be to the left, so W sine of alpha plus 600. So this will be x, resolving the forces along x-axis. Now we can basically, what we can do, we can reduce this a little to make more space for us to resolve this one. Okay, so this will be our more space which we can utilize. So F is what? F par is provided, which is this one, 22,500. So 22,500 and divided by velocity. This will be par is equal to F is equal to par over velocity. Par is given, which is 22,400. We have divided by V, and this will be equal to W, which is given 1,400 kilogram. So 1,400 multiplied by 10. So this is further multiplied by 0.1, which is 0.1, which is sine alpha value. So W sine alpha means this one, W sine alpha. So mass is 1,400 and G value is 10 and 0.1 is sine alpha value plus this 600, and so V will be equal to 2250, and we can multiply this by 1400 into 10 into 0.1, and this one in brackets plus 600, and we will simplify. This will give us the final answer for V, and with the help of calculator we can write 2250 in brackets. This will be again in bracket, and this will be 1400 into 10 into 0.1 bracket close and plus 600 and two brackets closed, and this is equal to, there is syntax error, means we have additionally placed a value. Basically 2500 should be divided by, this should be divided by. So what we can do, we can shift this one for division. We will be dividing this over this one, and we can write this one in brackets like this, and this will be equal to what? Now we can write 2250 over, this will be 1400 into 10 into 0.1, and this will be in brackets over here, and then plus 600. So plus 600, and this is equal to 1.125. Again, this is 10 we missed over here, so this should be 22,500 over here, and we got this one as 11.25. So this is equal to 11.25, and velocity will be meter per second, and this will be the final answer. Now we can move to the B part, and B part says the car moving with speed 11.25 meter per second comes to a section of a hill which is inclined to 2 degree to the horizontal. Given that the power and resistance force do not change, find the initial acceleration of the car up to this section of the hill. So what we will be doing, we can use the same drawing, and same drawing we can use from here, and we can paste over here, and this will be the drawing which we can use further for our question, and extra things we can remove. So this will be F force, and now in this part they are saying this is like the horizontal line which we can draw over here. This is horizontal line. Now this inclined plane is making an angle of this one, like from here. Now it is inclination is changed, and this is like 2 degree with the horizontal, and now the car reaches over here, and rest of everything remains same. So we can apply F is equal to ma for this situation. So now F minus 600, same thing, F minus 600 minus W sine of theta will be equal to ma, and force will be same, 2000 minus this one 600, and minus W will be 14,000 1400 multiplied by 10, so 14,000 sine of 2 degrees, and this will be equal to, we can move it over here, so this will be equal to ma, which is mass is 1400 into acceleration, and acceleration value we can write from here. So acceleration will be equal to what? This will be 2000 minus 600 and minus 1000, 14,000, and sine of 2 divided by, this will be 1400, and we can find the value of this acceleration by the help of calculator. So it will be 2000 minus 600 minus 14,000, and sine of 2 over 1400, and this will be equal to 0.651. This will be, they have not written, but we will be giving it 3 significant figures. So meter per second square, because this is acceleration. We are done with this. Now this is question number 3. Question number 3 says a particle Q of mass 0.2 kg is held in equilibrium by two light inextensible strings PQ and QR. P is a fixed point on a vertical wall and R is a fixed point on a horizontal floor. The angles with strings PQ and QR make with the horizontal are 60 degrees and 30 degrees respectively. Diagram is providing the detail. Find the tensions in the two strings. This is 5-mark question. to better understand, I'm just using this enlarged drawing so that we can better understand the concept. And this is the drawing which I'm using. It's the same drawing at a bigger scale, so you can see this one. If we draw the components, basically y component will be this will be the y component, which will be upward. Y component of what? This will be the tension, and this tension will, we can term it as TQP, and this will be upward tension, and y component will be upward, and this y component will be TQP, which is the name of the tension, and this will be sine of 60 degrees, sine of 60 degrees. And the y component of the same tension will be this one. So this is basically the y component of this tension, which is this one. We will write it as TQP, cos of 60 degree, and the direction will be right side. Similarly, we can understand the other tension which is over here. With this tension we can term it as TQR, and if we draw the y component of that tension will be this one, and we can draw the x component of this tension also, and this will be the x component of the tension, which will be having this direction, and y component, as we discussed, is in downward direction. Now these are the x and y components, and for this one, for y component, this will be TQR, and this will be sine of 30 degree, and this side will be TQR, cos of 30 degree. QR, cos of 30 degree. Hopefully you understood each and everything. Now this uh, ball or whatever object is having weight also, and that weight is having only the vertical component, so it's acting vertically downward. So we can draw downward arrow like this, and it will be W, and this will be equal to 0.2. They have given 0 point, mass is 0.2, so we can write 0.2 kg and multiply by 10. So um, this will be weight acting downward. So now this is the drawing which we have enlarged and shown properly. Hopefully you understood this. Now we can resolve x and y components, basically sigma fx, x component we can write here sigma fx. So forces along x-axis will be equal to 0 as the body is in equilibrium, and sigma fy is equal to 0. So x component, y component will be equal to 0. What are x components? So our x components are, this one is to the right, and left side is TQR cos theta. So we can write here TQR, TQR, TQR cos of 60 degree is equal to TQP, basically TQP cos of 60, and TQR this one also cos of 30. So this is cos of 30 degree. Now we can write TQP will be equal to TQR cos of 30 degree divided by cos of 60 degree. Now this one we can rewrite cos of 30 over cos of 60. So cos of 30 degrees divided by cos of 60 degrees, and this is equal to under root 3. So our value will be under root 3 TQR. So TQP, we got this relation basically, and that relation is TQP is equal to under root 3 TQR. Now, when we resolve the y component is what? Upward will be equal to, this force will be upward, and this will be equal to downward. Downward will be weight, and plus this will be downward, which is y component of this TQR sine of 30. So our relation, our equation will be what? Our equation will be TQR sine of 60 degree is equal to weight and plus TQR sine of 30 degree. This will be our relation. Now we can replace the values. TPQ is equal to QP basically. It should be TQP. We are confusing. So this will be under root 3 and TQR. This is value of TQP, which is this one. We have replaced this value over here, and sine of 60 degree. So sine of 60 degree will be equal to under 3 by 2. So we can multiply this by under root 3 by 2, and this will be equal to 0.2 into 2 will be weight, so that will be 2, plus this will be TQR, which is TQR we don't have, so sine of 30 will be what? Sine of 30 degree is equal to 1 by 2, so 1 by 2 TQR. Now further we can write 3 under root into 3 under root will be 3 over 2 TQR minus 1 by 2. We can shift this TQR to the other side, so minus 1 by 2 TQR is equal to 2, and this implies what? 3 by 2 minus 1 by 2 will be 1, so TQR is equal to 2. Now this TQR value we can replace over here, and we'll get TQP value, and TQP value will be equal to under root 3 into 2, or we can write 2 under root 3, and this will be the value of TQP, and this will be TQR. Both tensions we found. They are saying find the tensions in the two string, and we found those tensions. Hopefully you understood this. This was a 5-mark question. It will be very nice if you draw a drawing properly and resolve the forces and understand the upward and downward forces and rightward and leftward forces. Question number 4. An elevator moves vertically supported by a cable. The diagram shows a velocity time graph which models the motion of elevator. The graph consists of 7 straight line segments. The elevator accelerates upwards from rest to a speed of 2 meters per second over a period of 1.5. So from this to this, this is with the speed of 2 meters per second from 0 to 1.5, and then travels at the speed of 4.5 seconds for 4.5 seconds. So from here, this is 4.5 seconds before decelerating to rest over a period of 1 second. So for next 1 second, this one is deceleration, and this is for 1 second. Now the elevator then remains at rest for 6 seconds. So rest is from 7 to 13 for 6 seconds before accelerating to a speed of v meters per second downwards over a period of 2 seconds. So this is downward acceleration from 13 to 15. The elevator travels at this speed for a period of 5 seconds. So period of 5 seconds is this much, from 15 to 20, decelerating to rest over a period of 1.5 second. So lastly again 1.5 is deceleration up to this one. Now what we have to find, a part, find the acceleration of the elevator during the first 1.5 second. This is 1 mark question. So for this one, what we can do, we can consider this much triangle. There are two methods. One is you can just find the gradient of this triangle and slope of this line, which is from 0 to 1.5 seconds, and slope of that line will give us the acceleration. So m, or slope or gradient, will be equal to rise over run, and we can write it as 2 over 1.5, and this will be equal to 2 divided by 1.5 will be equal to 4 by 3, or decimal value will be 1.33, recurring 1.33 meters per second square, because this is acceleration. So this will be our answer. Now there can be a second option, which is we can apply equation of motion. V is equal to u plus at, and we know it's starting from from rest, so initial velocity will be 0, and final velocity is, we know, 2 meters per second. So v is equal to 2 meters per second, and time is equal to 1.5, t is equal to 1.5 seconds. So this data, if we replace in this equation, we will get v will be 2 is equal to 0 plus 1.5a. So a will be equal to 2 over 1.5, and we will get 1.33 meter per second square. So you can use any of these two routes and you will be getting same answer. Hopefully you understood. Now B part. B part says, given that the elevator starts and finishes its journey on the ground floor, find V. So velocity is required. For velocity, what we can do, we can compare the areas, and this is the area for this upper portion. We can take the trapezium basically. So this upper portion, this will be a rectangular portion, and this one we can write it as area A. Area A means two triangles, and this is the second triangle. So two triangles and one rectangle, or we can apply trapezium rule on it. And the second area will be area B, which we can consider this one as area B, and this will also be one rectangle and two triangles, or we can take it as trapezium. So this will be triangle and this one also will be the triangle. So we can term it as area B. So we can compare these two areas will be equal to each other as the elevator is moving up and then coming down also. So we can write down area A, area of shape A will be equal to area of shape B, and shape is what? Trapezium. So half into A plus B, opposite sides into height. So A plus B, opposite sides are, we can take this length, basically this length will be 6 minus 1.5 for this one. Basically I'm taking for this one, and this length will be what? 6 minus 1.5. 6 minus 1.5, this will be equal to 4.5. So this length is 4.5 and this total length is 7. So 4.5 plus 7. So this will be 4.5 plus 7, and height is 2 meters. This height is 2 meters. So we can 2 meters. So we can multiply it with 2, and this will be equal to the other shape, which is half into base into height. Base is what? Base is this one, opposite side, basically opposite sides, a plus b. So this is 5, and the total length, this one will be 7.5 7 no 8.5 meters, this one, and this one 5 meters. So 8.5 into 5, 8.5 plus 5, and velocity will be multiplied. V value we don't have. Now we can figure out, we can calculate the left side, which is 0.5 into, we can put brackets, and it will be 4.5 plus 7, bracket close, and multiply by 2, and this is giving us 11.5. So this side is 11.5 is equal to 0.5 multiplied by 8.5 plus 5, and this will be resulting to 6.75 V. So V value will be equal to 11.5 over 6.75, and this will be 11.5 divided by answer is equal to 1.7037. So 1.7 up to two significant figures. This will be velocity, so meter per second. This will be our final answer for this part. Now C part, this is the combined weight of elevator and passengers on its upward journey is 15 kilograms. So journey is upward, you will have to keep in mind journey is upward, and say this is the elevator and the combined weight. So there will be tension in the string that will be upward, and the weight will be from the center of mass, it will be acting downward. So this is W, and upward journey is passenger. So elevator, weight of elevator and passengers on its upward journey is 1500 kg. So 1500 multiplied by 10. So this will be weight, and this is mass provided, assuming that there is no resistance to motion. Find the tension in the elevator cable on its upward journey. So journey is upward when we have to calculate when the elevator is decelerating. So deceleration, we can calculate. How we can calculate deceleration? Deceleration will be equal to, we can calculate this one, V is equal to U plus AT, and V final velocity will be 0 because on the top it will stop, and initial velocity is U, plus A into T will be 2 A into, basically A, T is 1 second. So assuming that the combined weight of elevator and passenger is upward 15, assuming that there is no resistance, find the tension in the elevator cable. Okay, so it will be A will be equal to minus 2 meter per second square. This is the deceleration which we calculated. Now we can calculate, we can apply basically Newton's law on this, and elevator plus the person. So tension will be, because elevator is moving upward, so tension will be more than the downward force, and the downward force is what, 1500 multiplied by 10, and this is the downward force, and this will be equal to ma. So F is equal to ma, Newton's law we are applying. Mass is 1500, and deceleration we calculated as minus 2. So this means what? This means T minus 15,000 is equal to 3,000 minus 3,000 basically, and this will be T will be equal to 15,000 minus 3,000, and this will be equal to 12,000, and this 12,000 Newton will be the tension in the string which is upward. Hopefully you understood this. Now we can move to question number 5. Question number 5 says a block of mass 5 kg. So mass of the block is 5 kg, and weight will be acting downward, and weight will be W, which will be acting downward. Now being pulled along a rough horizontal floor. So rough horizontal floor pulled by this force, right? Xn. So Xn is the force, and when weight, we can consider the force diagram also. So weight will be balanced by the reactionary force, which is R, and because it is rough horizontal floor, so it will be having force of friction also, which will be acting backwards. So force of friction, we can write F, force of friction, and acting at 30-degree angle. So 30-degree angle, we can resolve the forces. Before resolving, we'll go through the question. Xn acting at 30-degree above the horizontal C diagram. The block starts from rest. So starts from rest means initial velocity is 0. So u will be equal to 0. This information tells us u is equal to 0, and travels 2 meter in the first 5 seconds. So in first 5 seconds, 2 meters mean distance is 2 meters and time is 5 seconds of its motion. Find the acceleration of the block. Now what we can do, we can extend this line like this one, and now we can, okay, I will redraw the line properly. Okay, now this one we can resolve this into two forces, and this will be upward force, this one, and this force will be xn, or x basically, n is for Newton. So x sine of 30-degree opposite over hypotenuse, so it will be sine theta, and this force will be what? This force, if I draw this force, will be this one. So this force will be cos theta, x cos theta. So this force will be x cos 30-degree, theta is 30-degree. So these will be the two components of xn, which now we can resolve the data given. We can write down u is equal to 0 and t is equal to 5 seconds. And what next? We are provided with s is equal to 2 meters, and we have to find acceleration, and we can use the equation s is equal to ut plus half a t square, equation of motion. S is 2, u is 0, so this term will be 0 plus 1 by 2 into a, and t square means 5 square, which is 25. So 2 plus this will be 0.5 into 25a, and a, this should be equal to, and this will be a will be equal to 2 over 0.5 into 25, and this will be equal to 0.5 over no 2 over 0.5 multiplied by 25, and this is equal to 0.16 meter per second square, 0.16 meter per second square. This will be acceleration which we're supposed to find. Now for B part, given that coefficient of friction between the block and the floor is 0.4, find x. So coefficient of friction we know is represented by mu, so mu value is given 0.4, and this is 4-mark question which we have to solve. So mu, we can write down the data given, which is mu is equal to 0.4, and now we can resolve upward forces are in balance. So x-axis and y-axis forces. What will be the forces along y-axis? Sigma Fy is equal to 0. Fy will be this force, and this force is also upward, and downward force is W, which is downward force. So two forces are upward, R plus X sine 30 degree. So we will write here sigma Fx is equal to 0. So upward force is R plus uh, x sine 30 degree. X sine 30 degree is equal to weight, and weight is what? Weight is equal to mg, and m is provided 5 into g value is 10, so this will be equal to 50. M is basically 5 kg mass is provided over here, which I wanted to show. So this weight will be equal to 5 into 10, which is equal to 50 kg. 50 Newton will be weight. So now we can resolve this one. Sine 30 is equal to sine of 30 degree is equal to 1 by 2. So we can write R plus 1 by 2x, we can write capital X, and this is equal to 50, and R is equal to what? 50 minus 1 by 2x. So we got this value of R, and now we will resolve sigma Fx. So if we resolve sigma Fx is equal to 0, sigma F x we have already resolved, so sigma Fy is equal. Basically we resolved first sigma y and we have written sigma x, so this will be sigma x and this will be sigma y. Now sigma y will be equal to what we are doing, we have resolved sigma y, we have correctly written this is sigma y because upward force is equal to downward force, and now we will be resolving sigma x. So this will be what we will be checking. The x-axis force will be one force, rightward force will be this one, and leftward force will be this one, and these are opposite to each other, so this will be equal to MA, so we can write x cos theta, so x cos of 30 degree minus F friction, because it is moving right side, so friction is lesser, so minus this is equal to MA. So this will be our force, net force, and this will be equal to MA. So Newton's law, F is equal to MA, we have applied. Now we can replace the values, and replacing values, cos of 30 degree, cos of 30 degree is equal to under root 3 by 2. So under root 3 by 2x minus force of friction is provided, which is 0.4 into R value, which is mu R. So 0.4 into R value, we can use this R value which we calculated. So it will be 50 minus 1 by 2x, and this is equal to MA, and mass is 5, and acceleration, we know acceleration is 0.16, which we calculated in the previous part. So we will simplify this one, and this simplification will be what? This will be, we will be multiplying under root 3 by 2x minus 0.4 into otherwise what we can do, we can keep as it is, into 50 minus 1 by 2x, and this is equal to 5 into 5 multiplied by 0.16, and this is equal to 4 by 5, or we can write 0.8. So 0.8 we are writing over here. And next step we will be rewriting under root 3 by 2 minus 0.4 into 50. 0.4 multiplied by 50 is equal to 20. So minus 20, and then minus into minus will be plus, and this will be 0.4 multiplied by 0.5, and this is equal to 0.2. So 0.2x is equal to 0.8. Now we can combine this x we missed. So this term and this term we can combine, and this will be under root of 3. We can take fraction first. So under root 3 by 2, and this will be plus 0.2, and this is equal to 1.066x. So 1.066x is equal to 0.8 plus 20. We have shifted 20 to the other side, and this will be, we can write on the next page. So x will be equal to 20.8 over 1.066, and this will be equal to 20.8 divided by answer is equal to 19.51, and this will be our final answer given that the coefficient is block. So x is basically this much newtons. So this will be our final answer for this part. Now for C part, the block is now placed on a part of the floor where the coefficient of friction between the block and the floor has a different value. The value of x is changed to 25, and the block is now in limiting equilibrium. Find the value of coefficient of friction between the block and this part of the floor. So this is 3 marks. Now we can resolve again. Sigma Fy is equal to 0, and this will be what, r plus 25. Now it will be x value is 25, so this will be 25 sine of 30 degree, and this will be equal to weight, and weight is what, same weight, so this will be equal to 50. Now we can resolve this one. R is equal to 50 minus 25 sine of 30 degree, and 25 sine of 30 degree. So we can calculate 50 minus 25 sine of 30 degree, and this is giving us 37.5. This will be the reactionary force. Now we can resolve sigma fx will be equal to 0, and this will be what, this will be 25 cos of 30 degree will be equal to force of friction, and force of friction is equal to mu r, and mu r value we just calculated this one, and we can replace. So it will be 25 cos of 30 degree will be equal to mu and 37.5. So mu value will be equal to 25 cos of 30 degree and divided by 37, and calculator will be giving us answer 25 cos of 30 degree and divided by 37 is equal to, this will be 0.585. So 25 cos 30 over 37, so 0.5557 basically 585. So 0.585, this will be our final answer for this part. Otherwise, this one basically we missed this 37.5. This should be 37.5. If we double check and write down here 37.5, our answer, yeah, under root 3 over 3. So we can write under root 3 over 3 and decimal value will be 0.577. 0.577. This will be the accurate answer for mu. Now question number 6. Question number 6 says a particle moves in a straight line. It starts from rest from a fixed point O on the line. Its velocity at time t seconds after leaving O is v meter per second, where v is given. This one v is given. This is the velocity function. So find the displacement of the particle from O when t is equal to 1. So it is given that initially starts from rest, so u will be equal to 0, and when time is t seconds, so this implies t time is equal to t seconds, and then v velocity, final velocity is equal to v. And what else? Now we have to find the value of s. To find value of s, we will be utilizing this v. When velocity is given, v is equal to t square in terms of t minus 8 t raised to 3 by 2 plus 10 t. So we know that integral of displacement is velocity. Integral of velocity is displacement, and derivative of displacement is velocity. So we will take integral of this. So integral of this, both sides will be, this will be s and this will be with respect to t, and this one we can write integral v dv. So this will be basically s on this side is equal to, not integral, this will be s, and this is equal to integral of this function, so it will be t cubed over 3 minus 8 t raised to 3 by 2 plus 1 over 3 by 2 plus 1 and plus 10 t squared divided by 2 and plus c value, which is constant. Now after taking integral, we know that at t is equal to 1, at t is equal to 1. So s will be equal to what? First we can check for at t is equal to 0. At t is equal to 0, this will be what? This will be, s will be equal to, if we replace t, this whole thing will be equal to 0. So this implies at t is equal to 0, s will be equal to 0, and if we replace 0 for s and 0 for t, we will get c is equal to 0. So this c is equal to 0 we will replace, and our final equation will shrink. S is equal to t cube over 3 minus 8 t raised by 3 by 2 plus 1 will be 5 by 2. So 5 by 2 over 5 by 2, or what we can do, we can write 5 and 2 will be multiplied by this, so it's 16, and this will be plus 2 into this one we can cancel, and 5 over here, so it will be 5t squared and plus c0, so I'm not writing that one. Now at t is equal to 1, at t is equal to 1, what will be the s value? So s is equal to 1 by 3 minus 16 into 1 by 5 and plus 5 into 1, and this one we can write 1 over 3 and plus 16 over 5 and plus 5, and this is giving us 128 over 15, that is 1 by 3, and sorry, it should be 16 minus 16 over 5. This one should be minus, and this is equal to 32 over 15, and the decimal value will be 2.133. 2.133 recurring, so we can write 2.1333 as our answer, and this is done. Now we can move to the B part, which says show that the minimum velocity of the particle is minus 125 meter per second. So for the minimum velocity, acceleration will be 0. Minimum velocity implies acceleration will be 0, and acceleration is what? Derivative of velocity. And now we can take the velocity. Velocity is what? Velocity is t square minus 8t raised to 3 by 2 plus 10t. This is provided. Now we can find dv over dt, and dv over dt will be what? This will be equal to 2t. I'm taking derivative of this one, so 2t minus this will be 8 into 3 by 2, and t raised to 3 by 2 minus 1 will be 1 by 2, and plus 10. So this will be the derivative, and we will put derivative equal to 0, and when we replace equal to 0, our term will be, we can do cancellation, so 2 4s are 8, and we will get 2t minus this will be 12t raised to 1 by 2 plus 10 is equal to 0. Now we can take 2 common, and inside will be t minus 6t raised to 1 by 2 plus 5 is equal to 0. And as 2 is not equal to 0, this implies t minus 6t raised to 1 by 2 plus 5 is equal to 0. Now we can write like for example, this implies what? This implies we can take the derivative, basically quadratic formula we can apply, or I'm using calculator, so coefficient of, we can write in terms of, like for example, t minus 6 under root t plus 5, and this one we can write under root square is equal to 0, and this will be coefficient of t under root square will be 1, then minus 6, and then 5, and this will be 5 and 1. So t under root is equal to, under root t is equal to 5, and under root t is equal to 1. So taking square on both sides, so t will be equal to 25 and t will be equal to 1. So these will be two values which we will be utilizing next. So we can find the second order derivative, that will be what? dA over dt will be equal to d2v over dt squared, and this will be what? This will be, we can take second order derivative of this equation, basically of this equation, this one, because this is the derivative. So 2 derivative of 2t will be t, and minus this will be 12 into power will be pulled first, so 1 by 2, and t raised to minus 1 by 2, and what else, 10, derivative of 10 will be 0. So this will be equal to t minus, and 2 will be cancelled with this one as 6, so minus 6 over t under root, this will be, this is not t, it should be 2 over here. Derivative of 2t is 2, so our equation, this will be 2 minus under root t. So 2 minus 6 over under root t. So when t is equal to 1, our second order derivative will be what? When t is equal to 1, So d2v over dt squared will be equal to 2 minus 6, 2 minus 6 over 1. So this will be equal to minus 4, which is less than 0. So this will be the maximum value. We are basically doing second order derivative test. So maximum velocity, as we are getting negative answer for second order derivative, so um, it will be maximum velocity at 1. And now we will check when t is equal to 25. So d2v over, so second order derivative will be what? This will be 2 minus 6 over 5, 6 over 5, and this will be equal to, we can calculate, this will be mode 1, so 2 minus 6 over 5, and this is equal to 0.8, which is more than 0. So this will be minimum velocity. So this will be minimum velocity. Now we can calculate velocity. Velocity will be equal to what? The given equation is t squared minus 8t raised to power 3 by 2 plus 10t. And maximum velocity, they are asking for um, minimum velocity. They are asking for minimum velocity, and we found that minimum velocity is when t is equal to not to 25, when t is equal to 25, velocity will be minimum. Now we will replace 25, so it will be 25 squared minus 8 into 25 raised to the power 3 by 2 plus 10 into 25. Now we can check for this one, and this will be 25 squared minus 8 into 25 raised to the power 3 over 2, and next is plus 10 into 25, and this is equal to minus 125, minus 125 meter per second. This is what we needed to prove, and this was required to prove. This was 7-mark question which we are done. Hopefully you understood this. Question number 7. Two particles P and Q. P is this one, Q is this one, of masses 0.5, mass of P is 0.5, and m kg, so m kg respectively, are attached to the ends of light in extensible string. The string passes over a fixed smooth pulley. This is fixed smooth pulley. No friction is attached to the top of two inclined planes. The particles are initially at rest. With P on a smooth plane inclined at 30 degree, to the horizontal, and Q on a plane inclined at 45 degree to the horizontal. The string is taut and particles can move on lines of greatest slope of two planes. A force of magnitude 0.8 Newton is applied to this direction. 0.8 is applied to P, acting down the plane, causing P to move down the plane. See the diagram. Now A part, it is given that M is equal to 0.3 and that the plane on which Q rests is smooth. Find the tension in the string. 5-mark question. First we have to find the tension. For this one we can first of all draw the force diagram, and force diagram will be what? We will know that tension in this string will be upward like this one, and there will be reactionary force which is like this one, so this will be force of reaction, and there will be weight acting downward, and weight will be like this one, and this will be mg, and we can draw the perpendicular. Basically we can resolve this force into two components, and those two components will be like this one. So this will be our triangle for that one. And now we can consider this force. There will be reactionary force on this also, and then this force will be, weight will be acting downward, and this weight we can draw 0.5 g, and we can draw the, we can resolve this mg into components, and this will be w sine theta, this one will be w sine of 30 degree, w sine of 30 degree. Now, and tension will be on, in this string tension will be like this one. So this is the force diagram which we have drawn. This will be tension, and we can say this is TQ, and we can say this is TP to distinguish them. And this is the force which is indicated already, which is 0.8 newtons. Now we can consider for this, we can consider this triangle for resolution of components of the weight. Now we can write on the equation on force. If we check for P, so on P, what will be the situation? It will be 0.8 newtons force. 0 on the left side will be 0.8 newton force, and plus w sine of theta. This will also be downward, so this is leftward, this force is left side, and this side is, this is left side, and right side is TP. So we will subtract, because object is moving down, so T will be lesser, so TP will be lesser, and this will be equal to MA, which is 0.5 into A. And now we can write the values of W, and W will be 5, 0.5 into 10 will be 5, so 5 sine of 30 degree, and minus this will be TP is equal to 0.5 A. Now we can resolve this one. This will be 5 sine 30. 5 sine 30 will be equal to 2.5. So 2.5 plus 0.8 plus 0.8 will be equal to 3.3. So this is 3.3 minus TP is equal to 0.5 A. And acceleration will be equal to what? Acceleration will be equal to 0. This will be, this is 0.5, or we can write it as 1 by 2. So 2 will be multiplied to this side, so it will be 6.6 minus 2, and tension, which we can write as TP. Now this is what we have considered. We have applied Newton's law on P. So now apply Newton's law on Q. So if we apply on Q, tension will be more because object is moving upward. So TQ will be equal to, will be basically, it will be upward, and minus W sine of 45. So minus W sine 45 degree, and this will be equal to MA. M is 0.3 and A, and we can calculate this. this will be what? This will be W is 3, so 3 sine of 45 degree, and this will be TQ, and minus, and this will be 0.3a, and we can rewrite it as 3 sine of 45 degree, and this will be equal to uh, under root 3 under root 2 by 2. So 3 under root 2 over 2, and this will be TQ, and we can shift this to the other side, and or otherwise we can write as it is. This is 0.3a. Now we can Now this a value we can replace by this a value which we calculated. So we will get TQ is minus 3 under root 2 over 2 is equal to 0.3 into 6.6 minus 2 TP. And as we know that the tension in both strings, this one and this one, both tensions will be same, so we can write TQ is equal to TP, and that is equal to T. So I have distinguished these two for your explanation, and this is T minus 3 under root 2 over 2 is equal to 0.3 into 6.0.3 into 6.6 will be equal to 1.98, and minus this will be 0.3 into 2 will be equal to 0.6, so 0.6, and this one also, instead of TP I'm writing T. Now we can shift this 0.6t to the other side, so it will be T minus 0.6t is equal to 1.98 plus 3 under root 2 over 2, and this one we can calculate 1.98 plus fraction 3 under root 2 over 2, and this will be equal to 4.101, and this will be T will be equal to 4.101, and divided by this will be 0.4. This one we can check. This will be what? This will be 1 minus 0.6 is equal to 0.4. It will be plus. When this minus will move to the other side, it will be plus over here, and it will be 1.6, and if we divide by 1.6, so 4.101 and divided by 1.6 is equal to 2.56, so this is equal to 2.56 newtons, and this will be final answer for this part. Now we can move to B part, and B part says it is given instead that the plane on which Q rests is rough. Now this is rough, it's having friction, and that after each particle has moved a distance of 1 meter, their speed is 0.6 meter per second. The work done against friction in this part of the motion is 0.5 joules, and use an energy method to find the value of M. 5-mark question, we have to use energy method, and we can say that the source of energy is equal to the consumption of energy, so, or utilization of energy, and we can say the left hand side we can take as source of energy, left hand side we can take as source of energy, and right hand side will be consumption of energy. and we can take gravitational potential energy, which is so first we will take gravitational potential energy, and plus this will be um, this one driving force, this will be dF on P will be equal to kinetic energy, and which is total kinetic energy, so we can write total kinetic energy, and plus gravitational potential energy of Q, and plus this will be work done against friction, so W against friction, this will be work done against friction, so work done against friction, and the values will be what, this will be 0.5 plus multiply, sorry, this one will be mgh, so it will be m, g will be 10, and h will be sine of 30 degree, 1 sine of 30 degree. This will be mgh plus driving force will be 0.8 into 1 meter, and this is equal to half mv square, so half, and mass will be 0.5, so 0.5 half m, so half plus m, so this will be 0 half into mass, this one will be mass, total mass 0.5 plus m into v squared, which is 0.6 squared, and plus this will be gravitational potential energy, which will be m into g into h, which is 1 sine of 45 degree, and plus work done against friction, which is 0.5. So now we will resolve this equation, and this will be what we can solve this one, 0.5 into 10 into sine of 30 degree, and this will be equal to 2.5, so this will be 2.5, and plus this will be 0.8, and this will be equal to what, 2.5 plus 0.8 is equal to 3.3, so we can write it as directly, we can write 3.3. 3.3 is equal to, this side will be 0.5 into, we can write as it is 0.5 plus m, and into 0.6 squared, so 0.6 squared will be equal to 0.36, and next will be plus m into 10 sine of 45 degrees, and this will be equal to 5 under root 2, 5 under root 2, and plus 0.5. Now we can shift this constant, which is 0.5, to the other side, and we will get 3.3 minus 0.5 is equal to, we can multiply this 0.5 into this one 0.5, and multiply by 0.36, and this will be equal to 0.09, 0.09, and now we will multiply m by this one, so plus 0.5 into 0.36, and this will be equal to 0.18 m, 0.18 m, plus this will be 5 under root 2m, and now we can shift this 0.09 also to other side, so it will be 3.3 minus 0.5 is equal to 2.8. So 2.8 minus 0.09 is equal to, we can combine these two adding like terms basically, so it will be 0.18 plus 5 square root of 2, and this is equal to 7.25. so 7.251, and this will be meters, and this side we can divide both sides by 7.251, and this side also 7.251. so m value will be equal to, we can write fraction 2.8 minus 0.09 over 7.251 is equal to 0.373 or 0.374. so 0.374, this will be kilogram. Mass will be mass of q, this will be mass of q which we were supposed to find, and we are done with this one. Use energy method to find the value of m. For q we have found. We are done with the question. Hopefully you understood each and everything, and don't forget to subscribe the channel. Also press bell icon so that you will be getting notification for incoming videos, and also don't forget to like the video and recommend this channel to your friends and classmates. Also introduce this channel to your respected teachers. Thank you very much for watching. Take care. Bye.